All right, let us take a look at this. The formatting on the front page is a little weird because it went from a PDF to a Word doc, but hopefully we should be able to get through it either way. So Pumpkin is launched from a platform into a field. The height in feet after t seconds is given by the equation h of t equals negative 16t squared plus 64t plus 64. So the first thing we need to do is fill out the table. So literally putting the numbers in for t and solving. So when I put 0 in, I should get 64. 1 gives me 112. 2 gives me 128. 3 gives me 112. 4 gives me 64. 5, negative 16. And 6, negative 128. So in this situation, t, right there, is the time in seconds. So it's important to note the units as well, so we're consistent right the way through. And h of t is going to be this right here, the height. And that'll be in feet. So the domain of our situation is all the x values that are relevant in the context of this problem. So the domain is the time from launch, my initial time, until Pumpkin hits the ground. And this is my domain. The range is represented by the height, that is the y values, and that's just at a given time. So the range is just going to represent the height of the pumpkin. So from there, we need to find the vertex. So I know my equation. So I'm going to use negative b over 2a. And b is 64. A is 16. Because they're both negative, I'm going to make them positive. So the x-coordinate of my vertex is 2. And then I have two options. I can plug it back in for t into this equation and solve, or if I've already done that in the table, at the time of 2, the height was 128. So my vertex is going to be 2, 128. Remember, the axis of symmetry is just the equation of the line that goes through the middle of the parabola. So if the maximum height has a time of 2 seconds, my equation is going to be x equals, and it's always going to be x equals because that's the equation of a vertical line, and the x-coordinate of the vertex, 2. So my axis of symmetry is x equals 2. So now graph the situation including label and scales. So y-axis is my height. in feet. And then the x-axis is my time in seconds. And I know I have a maximum of 128, so I'll go by tens. And looking at my table, I can see that somewhere between 4 and 5 seconds it's going to hit the ground. So I can still go by ones. And be on the graph. So now I'm going to plot some points. I know my initial height is 64 feet. After 1 second, I was at 112. 2 seconds, I was at my max of 128. 3, I was back at 112. 4, I was at 64. 5, I was at negative 16. Well, that's not going to be in the context of my graph because my pumpkin's not going underground. So I know it's going to hit here sometime between 4 and 5 seconds. So the y-intercept in this problem is 0.64. And it represents initial height. In other words, when the pumpkin was first in the launcher, it was 64 feet above the ground. The x-intercept in the problem represents the time the pumpkin hit the ground. And the maximum height, which I get from the vertex, was 128 feet. So if you got all that right, you should do well on the performance task. The other thing that may come up is may want to know what this exact point is as to when it hit the ground. And so to find that, I would replace the height with 0. And then either using completing the square, quadratic formula, I can determine what that point exactly is. So I notice all of these are divisible by 16. So that's what I'm going to do first, is divide everything by 16. And this makes my quadratic formula super easy. And so when I finally divide that all out in the quadratic formula, I end up with essentially 2 plus radical 2 and 2 minus 2 radical 2. I know this one's going to be negative, so I don't care about that. And this comes out to be about 4.82 seconds. That is what I would put in here as my x-intercept, 4.82, 0. All right. Short but sweet, 10 minutes. Hopefully that makes sense. If you still want to do a phone call or try and Skype or Zoom chat at 3 o'clock, that works for me. Um, Let me know what works best for you, and we can go from there. Have a good afternoon.